Well, kids, here we are, day 2 of digital learning. Day 1, kind of a cluster. I could see from emails and messages and things that I got from students and from other staff members, some things worked well, other things didn't work very well. Bottom line is, we're just going to do the best that we can and make sure that you communicate with the teachers, the principal, the counselors. We don't want you to struggle. We want to help you, but you have to reach out for us in order to get a lot of that help. So, just a couple of things about yesterday's lesson. First of all, here was the little quiz that you were supposed to answer and have turned in before today. So if you haven't done this yet, make sure that you do it. But when we look at the quiz, there were several questions that students had. For instance, the first question: which layer has the coldest temperatures? And so when I look back in the textbook here, and I'm going to find that thermal graph, which, by the way, you were supposed to put on the worksheet as well. There's a red line. When the red line is towards the right, we have higher temperatures, as is shown here with the numbers at the bottom. When the line moves to the left, the temperatures go down. So colder temperatures are going to be as far to the left as possible, and a little bit tricky, but right here in the bottom of the thermosphere, you can see that we have the coldest temperatures in the atmosphere are located here at the bottom of the thermosphere. Now the mesosphere itself is pretty cold, compared to the other ones, but the coldest temperatures right here in the bottom of the thermosphere. Coincidentally, the thermosphere also has the highest temperatures, way over to the right and actually off the scale. So there were some questions about temperature, and you were supposed to fill in a question at the bottom. What's your take on that? How do you think that happens? And really, it's all about, and some of you had nailed this, that the different gases in the atmosphere at different layers do different things with the heat. Some of them absorb heat, so any gases that absorb heat are going to be warmer. Any gases that don't absorb heat are going to be cooler. So that helps to explain a little bit about why we have different temperatures at different layers in the atmosphere. Also, up here, the higher we go away from the surface of the Earth, the less amount of gases that there are. Gravity is pulling all of those gases, as much of them as possible, towards the surface of the Earth. So the higher you go, the less there is. That's why it's hard to breathe when you climb Mount Everest. There's less oxygen up there. So there are less molecules up there. So any of the sun's rays that hit those molecules way up here in the thermosphere, there's not much competition. So all of that sun's energy is on just a few molecules, and it heats them up very quickly. They move very fast, and that's why those temperatures are kind of off the charts. But the right answer is for temperature up here in the top of the atmosphere and in space is this. If you're in sunlight, it's warm. If you're not in sunlight, it's very cold. So that should address some of those questions. Frickin' kids, I tell you. Now, some other questions that you had. 2 layers where the ionosphere is located. I did go over that yesterday. Information from the book that went on to state that right here, the definition of ionosphere is that it's in the mesosphere and the thermosphere. Mason, I believe it was, correctly pointed out that I had that wrong in the answer key. I did go ahead and change that. So hopefully that's up to date as well. So these questions, 2 most common gases, we went over it in class. I did have it in the lesson yesterday as well as the solids in the atmosphere. But I did want to just show you in the packet that we have, and I'm looking at the first page, section 1 notes, atmospheric makeup, the different layers, but right here, atmospheric gases, and which ones are the most common. Down here, we've got the solids in the atmosphere, which are right here. So those would have been two of those questions. So really the great majority of the answers to those questions could have been found just on that first page of notes as well. You have to put in the work. You have to look for those things. I saw some evidence of just kind of guessing on certain things, and that's not going to do you a service at this point. All right. Now, I told you that today's lesson was going to be on the ozone layer and pressure, because the second part of the assignment is this sheet. This sheet right here needs to be completed, and you're going to turn that into me on Monday. All right, we did some of it yesterday where you were supposed to label the layer names. You're supposed to put the distances here on the lines, the heights for each of those layers. We talked about how to find the two things that can be found in each layer. You might have to look at pictures in the book. You might have to Google some of those things, but make sure you write in here a couple of things that can be found. We also talked about the ionosphere a little bit yesterday. Today is about ozone layer and pressure. So actually, let's start with pressure. And what I want you to do is, when you're looking in the book again, you can see on page 429, it talks about atmospheric pressure. It will explain all of this right in that section. Also, this graph helps to show what's going on. So if you look down here, this is the altitude. So 0 means we're at the surface, and 10 kilometers, we're going up and up and up and up as we go over here. And when we look along this axis, you can see that pressure in millibars is highest. It's up here around 1,000 or higher right at the surface. And as you go higher into the atmosphere, the number goes down and down and down. So the short answer is this: pressure, atmospheric pressure, is highest at the surface of the earth. You are carrying around on your shoulders and on the top of your head in the neighborhood of 1 ton, 2,000 pounds of air, gases that are being pulled towards the center of the earth, and your shoulders and your head happen to be in between the center of the earth and those gases. So we've got a lot of pressure pushing down on us. We don't notice it because it's been there since we were born. So we don't feel that pressure. This is going to be helpful when we talk about weather in the coming days. Once we get through the atmosphere section, I tell people to think of the pressure at the surface like a scale. There's a scale down here on the surface of the earth, and the higher the pressure, the more air that's being pushed down towards the surface, the higher the number on the scale is going to be. The lower the pressure, the less those gases are being forced down towards the center of the earth. So the lower the number will be on the scale. So the short answer: pressure is highest at the surface and lowest away from the surface. The higher you go towards space, there'll be the less amount of pressure. All right. So make sure that you indicate that on this picture. There doesn't need to be the graph or anything. Near the surface here, you're going to put highest pressure, and up here towards the top, you're going to put lowest pressure. Maybe a line with 2 arrows on it that show, all right, as I'm moving up, I'm going to get a lower pressure, and as I move down, I get higher pressure. The second new thing for today is the ozone layer. And again, looking in the book here towards the end of the section, 432 talks about the ozone layer and what it does for us. First of all, where it's located is in the stratosphere. You'll notice that has an impact on temperature when you compare where the ozone layer is to your temperature graph. The ozone layer does several things for us. It blocks ultraviolet radiation from the sun, which, as we know, UV rays, and that on our skin, it can lead to skin cancer. It can lead to sunburn, first of all, but then, with prolonged exposure to skin cancer, it's bad for plants and other animal cells as well. So the ozone layer is really a protective blanket for us that protects us from the sun's ultraviolet rays. It goes on to talk about what we've done to damage the ozone layer. if you've ever seen a picture of grandma or aunts or uncles, maybe moms, dads in the 80s, they all had big hair, big bangs, big hair. And how they got that was hairspray. And hairspray and other things that like Glade spray, those aerosols, they used CFCs, or these chlorofluorocarbons, to push out the material that's in the can. And CFCs, it goes on this six-part process here, but basically the CFCs destroy ozone, and they destroy a lot of ozone. One CFC molecule can destroy thousands of ozone molecules. So once we figured that out, we also stopped using them in refrigerators and aerosol cans, those kinds of things. And we figured out that that is helping the ozone layer to heal. And you can see here these different colors indicate where the ozone hole is located because of those CFCs. And over time now, that hole is slowly being repaired. Just an example of scientists using information, using evidence that we have to solve big global problems. All right. So, what to do next? Just a reminder, that should cover everything on this sheet. We've got the layer names in these 5 boxes on the right. We have the temperature. You're drawing the red line and labeling the numbers across the bottom here. 2 things can be found in each layer. I should see things like meteors and space shuttle and airplanes and those kinds of things. 2 for each layer. You might have to Google search those. The ozone layer, you're going to draw it probably up here in the stratosphere. Make sure it matches up with what you found in the book. Ionosphere was yesterday's stuff. High pressure and low pressure. Again, that'll be along the side, and the distance measurement. So once this whole thing is done, I'm going to open a bucket in Google Classroom for you to dump that into. We'll have to see if you turn in the whole packet or just take a screenshot of it and turn it into me. I haven't figured that out yet, but we will figure that out before Monday when I have you have that due. In the meantime, then tomorrow is Saturday, and so hopefully you've got all this stuff done. But today there will be another quiz in Google Classroom, and I'm calling them quizzes. They're just a couple of 3, 4, 5 questions that are the big ideas from the lesson. Take your time when you answer those. I have to assign you grades based on how you do on those little quizzes. It also helps with attendance so that we know who's doing what we need them to do while we're not able to be together. So make sure you take your time with them. If there are questions and concerns that you have about the questions, things don't make sense, I am highly recommending Google Hangouts. All right, this is an example of Google Hangouts. I have an Earth Science Hangout with all of you in it. If you have questions, you should be messaging me in the morning as you have those questions so that I can help you and help others. We can all benefit from everyone's questions. You can see that I also have individual students I've invited to Google Hangouts. If you have an individual question, just shoot me a message through Hangout. It's going to be a lot quicker than trying to go back and forth between emails and those kinds of things. So please use Google Hangouts. If you don't know how to use Google Hangouts, ask a friend, email me, email the group, post a comment in the Google Classroom that you have, and someone will help you to figure out how to use Google Hangouts. All right. So in the meantime, take care of yourself. Make sure that you are washing your hands, you're practicing your social distancing, and hopefully learning a little something about the atmosphere along the way. So, with that, we're going to sign off for the day. And, I feel like I'm getting pretty famous. There were almost 100 views of my video from yesterday. So, I don't really know what it takes to become viral, but I think I'm there already. So, let's keep this going, and we will talk to you soon. Take care and have a good weekend.